Hi guys, today we're going to look at how to find the explicit formulas for arithmetic and geometric sequences. So I'm in the days 2 through 3 note packet. So if you look, the note packet I'm in looks like this. So you should have this from yesterday. So go ahead and get this out. And then I'm the third page in, I believe. So the fourth page. So what we're going to look at are the explicit formulas. So if you remember what I talked about with explicit formulas, it basically just means that I'm going to be able to have a formula where if I want to find the fifth term, I would plug in 5 for n. Or if I want to know the 10th term, it means that I'll be able to plug in 10 for n. So both of these equations down here are going to be used to find the explicit formula. The good thing about these two formulas, they look complicated, but they're given to you on your reference table for the Regents exam and for any in-class exam. So I'm just going to make a note of that these are given on exams. So that's good news. So we have two different formulas here. We have our arithmetic formula and our geometric formula. So remember, arithmetic means that you're adding a constant number, where geometric means you're multiplying by a number. So each of them have this a sub 1 term, so a subscript 1 term. So that basically just means they each require you to know the first term of your sequence. And then the difference here is the arithmetic has this d term, and this is going to be the number that you're adding each time. So they call it the common difference. So this is the number being added, where the R stands for the common ratio, and all of these are right down in here. So common difference, common ratio, but this means you're going to insert the number that's being multiplied by each time. So this is the number being multiplied. So in the end, in order to come up with your formula, you have to know two things for each situation. You have to know the first term and either the number that's being added or the number that's being multiplied. Remember, when I say the number being added, I also mean adding negatives, so really which will look like subtracting. And if I'm talking about multiplication, well, if I'm dividing by something like 2, that's really like multiplying by 1/2. So just kind of keep that in mind. So in the end, too, your subscript has an n for the formula, which means your answer should have an n in it. So n is going to kind of work as that input variable, or that like an x, because that's what you're going to be plugging in for. So if I want to know the 10th term, I would replace n with 10, and I should be able to get the 10th term. That's what these formulas are going to do. So let's try some examples using these formulas. So the first thing you need to always do is you need to analyze the sequence, and you need to decide, is it arithmetic or geometric? And then if it's going to be arithmetic, we'll use our arithmetic formula. Geometric, we'll use a geometric formula. So I need to decide, is there a number being added or multiplied each time to get this sequence. So if you analyze this first one, you want to ask yourself, okay, well, what's happening to go from 2 to 6, 6 to 18, 18 to 54, and it has to be consistent. So ask yourself, am I multiplying or am I adding something? And I'm seeing that I'm multiplying by 3 each time. So if you're not sure, you could just divide, do 6 divided by 2, 18 divided by 6, and see if you get the same number. So it's going to be times 3, times 3, times 3 would be the pattern. So since it's being multiplied, this tells me I have a geometric sequence, which means I'm going to use the geometric formula. So a sub n equals a sub 1 times r to the n minus 1. And remember, geometric means you're multiplying, which is exponential, which is why you have an exponential function versus a linear for arithmetic. So I need to know two things. I need to know a sub 1, and I need to know what r is. So a sub 1 is going to be the first term. So that's going to be 2. So this is a sub 1. And your common ratio, or the number you're multiplying by, is going to be 3. So then what you do is you're going to take these things and you're going to plug them into your formula. So a sub n equals a1, which is 2, times r, which is 3, to the n minus 1. And I'm just going to put that 3 in parentheses because it's the 3 that's being raised to the n minus 1, and the 2 is getting multiplied out in front. So essentially all I did was I plugged in the 2 for a1, 3 for r, and I keep the n minus 1. And you can't simplify this any because you can't multiply 2 times 3 because the 3 belongs to the exponent and the 2 doesn't. So this is it. You just keep it just like this. So the geometric sequence formula you're going to find, you can't really simplify, so they're actually easier because you just leave them as is. So that's it. So if I wanted to find the 50th term, I'd plug in 50 for n, plug it into my calculator, and I'd get the 50th term. So that's what the explicit formula is doing. So if we look at the next example here, first thing you want to do is decide, is this arithmetic or geometric? So I look for a pattern. So you can try dividing the numbers or subtracting the numbers. So if you're trying to decide if it's multiplication, divide 3 divided by 1 and see if that's the same thing as 5 divided by 3. If you're trying to decide if it's arithmetic, do 3 minus 1, see if it's the same thing as 5 minus 3, and if it's the same thing as 7 minus 5. You just do the opposite if you can't see the pattern. This one I'm seeing is a +2 pattern. So that tells me it's going to be an arithmetic sequence. So that means I'm going to use the arithmetic formula. So a sub n equals a1 plus n minus 1 times d. So we have to know two things, just like the other one. So a1 is the first term. So a1 will be right here. So a1 is going to equal 1. And then d is going to be your common difference. The number that you're adding is going to be positive 2. So then you're going to take those and you're going to plug them into the formula. So a sub 1 equals 1 plus n minus 1. And remember, n minus 1 always stays in these, or just the n stays. And then you replace d with 2. And really, you could leave this as an answer, but if this was a multiple choice question, they wouldn't leave it in this format. They would actually want you to multiply through and simplify and combine like terms. So pretend for a second the 2 was out in front. You're basically just distributing. If I want to get rid of those parentheses, I'm just going to distribute that 2. If it makes you feel better, put it in front and then distribute. So in the end, I have 1 plus, so then 2 times n gives me my 2n. 2 times negative 1 will give me minus 2. Combined are like terms here, so I have 1 and negative 2. So this will end up being a sub n equals 2n, and then this will give me minus 1. And there's your equation. And again, arithmetic means you're adding, which should be a linear looking equation. So this kind of looks like y equals mx plus b. So that's why you end up with a linear looking equation versus an exponential for the previous example. So that's it. So if you plugged in, again, if you wanted to know the 100th term, you'd plug in 100 for n, and it would give you the answer. So let's just do some more examples, just with some different looking, or some problems that are a little bit harder to find the pattern. So if we look at this next example, write an explicit formula for this sequence. So now I see decimals. So as soon as I see decimals, I'm thinking, okay, it might be a little bit more difficult to find the pattern. So remember, go backwards. Try subtracting. So do 3.5 minus 0.5. You get 3. If I do 24.5 minus 3.5, I will not get 3. So it tells me it can't be arithmetic. So then try dividing. So if I divide 3.5 divided by 0.5, I end up with 7. If I do 24.5 divided by 3.5, do I get the same thing? And the answer is yes. So since I can divide the second term by the first term and the third term by the second term, and I get a constant number, that tells me that 7 is that common ratio. So times 7 is the pattern for this one. So since I'm multiplying, it's going to be geometric. So write down our geometric sequence. So a sub n equals a1 times r to the n minus 1. Identify our unknowns here. So we have a1 is going to be the first term, is going to be 0.5. Common ratio is the number we're multiplying by, which is going to be 7. Take those and write them in the formula. So a sub n equals a1, so 0.5, times 7 for the common ratio raised to the n minus 1. And that's it, because you can't multiply the 0.5 and the 7 because 7 belongs to the exponent. So 7 belongs to the exponent, but 0.5 doesn't, so you just have to leave it like that. So let's try a few more together. So this next one here, worded a little bit different. First thing I see is my sequence, and it's asking me to find the 10th term. So if I want to know the 10th term, yes, you could just keep doing the pattern to get the 10th term, but if looking at part B, it wants me to know find n when the sequence has the term 209 in it. So that tells me I need to know this formula. So the first thing I'm going to do here is I'm going to find the formula. So first, find the formula. So if we're going to find the formula, that's really always going to be your best bet with these. If I'm going to find the formula, I need to figure out the pattern. So when I look at this, these are odd numbers, which means I'm adding 2 each time. So if we're adding 2, that means it's arithmetic. So this part will be exactly the same. So your formula, a sub n equals a1 plus n minus 1 times d. a1 is the first term, is going to be 3. d equals 2, the common difference. Plug those in and then we'll simplify. So a sub n equals 3 plus n minus 1 times 2. Then you're going to distribute to simplify and combine like terms. So we have 3 plus 2 times n, so 2n minus 2. So we end up with 2n, and then combine these, we have plus 1 at the end. So here's our formula. Now remember, if you write this as 1 plus 2n, that's fine. Because addition's commutative, you can switch the order. It doesn't make a difference. So if I'm trying to find the 10th term, is what it's asking for. That means n equals 10. So I'm going to use my formula to find the 10th term. So again, n equals 10. We're going to plug in. So a sub 10 means the 10th term of the sequence. So 2 times 10 plus 1. So I'm just plugging into this formula. I'm using that formula to solve this problem. And when you do this, we'll get 2 times 10 is 20 plus 1. So we get a sub 10 equals 21. So the 10th term is 21. So that's the first part of this. So now the second part is asking us to find n if a sub n equals 209. So that means it wants us to find what term number is 209. So this time we have our formula, so I'm still going to use this formula again. So a sub m equals 2n plus 1, but instead of plugging in for n, I'm trying to find n, I'm going to plug in for a sub n. I'm going to take 209, I'm going to plug it in for a sub n. So 209 equals 2n plus 1, and I'm just going to solve this like a normal equation. So subtract 1, so we get 208 equals 2n. Divide both sides by 2, so you get 104 equals n. So what that means, it's saying that when we're looking at the 104th term, that's going to equal 209. So this means the 104th term, because that's what n is 209. So these formulas can be used in a couple different ways. If you know the term number that you want to find, you can plug that in for n. Or if you know the number of the sequence and you want to know where it occurs, you could solve it this way. You can plug in that number of the sequence for a sub n and then solve for n. So there's a couple different purposes of the formulas. So then the last problem we'll look at together is number 5. And that's going to just be another, okay, we want to find the 11th term, so we're going to find the formula first and then just plug in 11. So these are kind of, this page is really just kind of like the applications of, okay, we found the formulas, now how do we use it? So if we're trying to find the 11th term, let's find the formula first. So if I'm trying to find the formula, we are going to look for the pattern. So again, if you're unsure, try dividing, like the second term divided by the first term, third divided by the second, or try subtracting until you get something consistent. So if you were to divide, you would get -1/2 each time. So -1/2 divided by 1 is -1/2. 1/4 divided by -1/2 would give me -1/2. So that tells me the pattern here is times -1/2. So times -1/2. So that means this is geometric. So we have a sub m equals a1 times r to the n minus 1. And we have our first term then is going to be 1. And then our common ratio is going to be -1/2. So that's the number that you're multiplying by. So when we combine these, we have a sub m equals 1 times 1 -1/2 raised to the n minus 1. And you don't really need this 1 in front because 1 times anything will just be whatever that number was. So you could just rewrite this if you wanted. A sub n equals -1/2 to the n minus 1. You want to make sure that you have parentheses, especially for this one, because it's -1/2 being raised to the n minus 1. It's always that common ratio being raised to the n minus 1. So here's your answer. Either of these are acceptable. And then from here, the second part is going to be to find the 11th term. So this was part 1. Part 2 is to find that 11th term. So that means you're going to use your formula and let n equal 11 and plug in 11. So I have a sub 11 equals -1/2 to the 11 minus 1, which really means -1/2 to the 10th. And I would simplify that first before you put it in your calculator. If you do put it in your calculator, just make sure that that whole thing, the caret, you hit caret, and then that whole thing is an exponent. So if you raise this -1/2 to the 10th in your calculator, you will get 1/1024. So there's your answer to this question. So the 11th term is 1/1024. So that's it for this. So now you guys are going to work on the classwork worksheet, where you're going to have to go through the same process. You're going to have to find the formulas. So you're going to decide on if it's arithmetic, geometric, find the formula. And then you're going to do some problems where it's going to give you the formula, and you're going to find 5 terms. So that just basically means plug in the numbers. Whatever terms you want to find, you just plug in. If I want to know the first term, second term, you just plug in for n. And then once you know your terms, then you can decide is it an arithmetic or geometric sequence.